begins with some new identities, and there are 4 of them. And these are saving people from a classic mistake, because back in the day, people might have been tempted when they saw that to think that all they had to do was do sine 15 and sine 75 and add them together. That's called distribution, when it doesn't matter whether you write something once or write something twice. A very famous example of that is roots. It does not matter whether you write the root symbol twice or the root symbol once. That's 2, that's times 3, so that's a 6. That's the square root of 36. So that's 6. So this is clearly sweet. Distribution is not always the case though. So that's a 5, right? If you do the square roots separately, you do not get 5. You get 7. Don't you? Okay. This is wrong. Okay. So sine does not distribute over a bracket. It does not distribute over plussing. Okay. And I mean, it's a tragedy if somebody thought they had to do it this way, because that question is so easy. That's just sine 90. Yeah. But wouldn't it be sweet if the 2 things in there were easy to work sine on their own, whereas if you add them together, it's not so easy. Like, nobody knows what sine 75 is without a calculator, but we do know what sine 30 and sine 45 are. So it's a shame that we can't do that. But what we can do is use these new formulas. Okay. Now the new formulas are these. Sine A plus B is sine A cos B plus sine B cos A. So basically it's a lot of effort. You have to do 4 trigonometries instead of just 1, but at least you get to work on the individual fellows. So what is sine of 30 plus 45? It is half 1 over root 2 plus 1 over root 2 root 3 over 2. Yeah, so we can get an exact answer much quicker. Okay, now you tidy that up obviously and stuff. I think that tidies up quite nicely. You can even rationalise the denominator on it if you want. But the point is, that came out super fast without a calculator. Yeah, and the only reason why it came out super fast is because I knew off by heart what sine 30 was. Yeah. Now there's another three of them. Sine A minus B. If you don't want to remember this next one, I can't force you to. And there's a great little cheat you can use if you don't want to remember it. Whenever you see a subtraction in the whole of maths, you can pretend it's the addition of a negative. So I can use that one up there. You cool with that?
Yeah.
Now, sine A is obviously just sine A. What's cos of negative B? Is there a better way of writing that? Or alternative way of writing that? If you switch from B to negative B, if you switch from B to negative B, does that make any difference to the cos? No, it doesn't, because you're still the same distance over to the right. So there's a better version of that, it's just cos B. Yeah? What about sine of negative B? If you switch from there to there, does it make any difference to what sign comes out? Not to the decimal you get, but it does make it negative. Yeah? So in fact, that's your next one. Sine A minus B is equal to sine A cos B minus sine B cos A. Yeah, and I recommend learning that, even though I gave you a little cheat method for not learning it. Basically, in the whole of maths, you never need to learn anything that has a subtraction if you already know something that has an addition, because all subtractions are the same as adding a negative. So therefore, our formulas so far are those. Now, here are another 2. Oh, in fact, there's another 4 to come, I'm sorry. Okay, So cos A plus B is cos A cos B minus sin A sin B. And cos A minus B is cos A cos B plus sin A sin B. So there are 4 formulas so far. Now when I'm trying to remember these, I remember that sine is the one that mixes stuff together, yeah, like Britain, whereas cos is the thing that keeps people apart, like Australia. Okay, so see how the coses are together and the sines are together?
Yeah.
The other thing is that if sine works on a plus, there'll be a plus in the formula. If it works on a minus, there'll be a minus in the formula, whereas cos switches it over. Cos A plus B is those minus each other. Cos A minus B is those added together. Okay? And you can use them in exactly the same way that you can use those in order to do things fast. Finally, tan A plus B is tan A plus B plus tan B over 1 minus tan A minus tan B. And tan A minus B is tan A minus tan B over 1 plus tan A tan B. Yeah, and they get used in exactly the same way. Okay, now I've already shown you a typical question, which is just to do things fast like that. Yeah, let's just show you some other classic things. Okay, so one thing is to prove identities.